Right. Well, thank you. Can you hear me? All hear me okay? Good. Well, thanks very much for making it this afternoon. FreeDV is a way of sending voice over HF or VHF using digital techniques, and its particular forte is its very narrow band and that it can work in very poor signal-to-noise conditions, which I have a live demo of later in the talk. So keep fingers crossed, because, you know, as we were saying earlier, demos have a habit of not always working quite as you would have liked. Okay, so and the reason I wanted to talk about it is because it's all developed by amateur radio enthusiasts around the world. There is one guy who has really spent a lot of time on it, for which we have to thank David Rowe, and I've got his call sign later. He's from Australia. But I think it's, it's an interesting mode to experiment with. It really is a bit of experimentation on HF. It's the first new method of sending voice on HF since the 1950s, when people started to use sideband. And two, I think it's an amazing piece of work for a group of radio amateurs from different parts of the world. So the agenda today, a little bit about what is it. I hope I can convince you it's worth your time to take a look at. There's just a little bit about how the voice coding works, and I'll try not to labour on that. Probably some of you know far better than me, and for others they probably think, well, I don't really want to know that much detail, so I'll try to pick a middle way between those extremes. Information about how to get on air, which is quite straightforward. A bit about the different modes, what's happening now currently in the UK, and then this demo, which I'm hoping I will see jaws drop at the point that the demo works, and so on. And then, of course, questions. So what is it? Well, it's a piece of open source software to send voice using a digital codec over VHF or HF radio. The software includes the application that you see on the screen, but it also contains the voice codec itself, a special new modem developed this year for sending data over HF as reliably as possible, and it's able to withstand multipath fading and poor signal to noise, and still have a robust data connection. And the data rate is around 900 bits a second over the air, and it's quite narrow bandwidth in 900 hertz essentially. So there's a lot of work been put into that modem, over 2 years work of optimization to make that work. And then, of course, there's the user interface. There is an API, so a set of software that you can take the source code, and you can embed it in your own applications and products should you want to. And there is a pre-built adapter if you want to buy that. But the design of the pre-built adapter is available, again, all open source, so you can just download the design and make your own if you prefer, rather than buy. Essentially, at the moment, there are two modes. There's an HF mode, where the codec is running at about 700 bits a second, and there's a VHF mode where there's just a little bit of extra bits, and it's at 800 bits a second. And there's a new mode in development, which I will show you a video of. So why is it worth your time? Well, as I said, I think, you know, FreeDV, it's the first real change in how we might send voice over HF since the 1950s. And I personally think it might well be certainly part of the future of HF voice. It can give a reliable voice communication link that's understandable at a signal-to-noise ratio of about -2 dB, and that's what I plan to demonstrate today. So I don't think we're quite at -2. I think we're about 0 on the demo, but it's very, very poor. And comparing with sideband, you'll really hear a noticeable difference. And on VHF, it's capable of a link budget that's 10 dBs better than achieved by DMR or D-Star. So 10 dBs, you know, that's multiplying your power by 10 times. So you could really see range improvements for portables and repeaters if they were to use some of these techniques in their design. It's completely open source hardware, any hardware, and also open source software. That means anybody can take the source, they can adapt it, change it, and put it into their own applications, products, experiments, whatever they want to do. The codec itself developed is called Codec 2, and it's called Codec 2 because he had a go, and that was called Codec 1, and then thought, right, well, no, that doesn't work, so I'll make another one, and that's called Codec 2, by a gentleman called David Rowe, VK5DGR. He has a very interesting blog. I recommend you take a look if you're interested, discussing everything from low bitrate voice codecs to high altitude balloon telemetry to building your own electric car. So it's an eclectic read. There's no hardware, there's no £100 dongles just to be able to use the voice codec because the codec is open source, unlike the codecs in D-Star or DMR and those other digital systems, which are of course closed. That will mean every brand, every radio of every brand or homebrew can talk together with no company lock-ins, you know. Oh, I've got DMR and oh, I've got D-Star, and then you get a D-Star repeater and everybody in the area has to buy ICOM or whoever in order to be able to talk to each other. And it's a genuine piece of amateur experimentation and development. So no big companies involved, just some dedicated amateurs, and it's a real achievement. The codec is better than achieved in the commercial world. Right now, this is the best low bitrate codec in the world, developed by radio amateurs. So it's a big deal in my view, and that's why I've bothered to come here and tell you about it. So we can get good quality voice in about 1.5 kilohertz. It's a little bit narrower than sideband. There's no background noise, and there's no crashes and bangs and so on, although there are codec artifacts. So, you know, you hear some twangs and noises, but it's a bit less tiring than listening to a bad SSB signal. Now we've got the voice in digits, and it's essentially a digital receiver. It should be possible with further work to perhaps produce DSP processing that can take some of the signals out of the noise, which we all suffer on HF these days from the DSL systems and all the other noise sources in people's homes. You could use spread spectrum as a transmission technique and do experiments there to go below the noise floor even further. And it would even be possible to produce a single frequency duplex repeater on HF. So because you can now, if you made the modem go faster, you can have slots for receive, slots for transmit, and so one station can be talking and the other one listening from a repeater. So it would be possible to produce narrowband simple HF repeaters based on digital voice, were someone to want to do that. Okay, so that's why I think it's worth your time. Just looking a little bit at the codec, and I am not in any way qualified to talk about this subject, so please bear with me. But essentially, if you were just to sample the analog signal of the voice and sample it with enough bits and fast enough to get a telephone quality channel, or a bit less than telephone quality channel, the absolute minimum sampling rate would be about, would get a data rate of about 48,000 bits per second. So clearly 48,000 bits per second on an HF frequency is far, far, far too big. You take up the whole of an HF band with just one signal. So that isn't obviously a practical thing to do. So you need to reduce the amount of data needed to send the voice from this 48,000 bits down to a much more reasonable number of bits per second. You could try using some form of lossy codec like MP3, but you run it, one, again, it doesn't get you down far enough, and two, you get the problem that if 1 or 2 bits become corrupted, the whole message is corrupted, because now you've processed that so much in a relatively long frame that, again, you're very, very susceptible then to interference. So the way that these low bitrate voice coders work is they create a model of human speech, and in the case of Codec 2, it's what's called a sinusoidal speech coding. So it essentially says that speech is made up of tones, which you vary the pitch of the tone in your voice box, and then the tones have harmonics, and each of those harmonics is at a certain amplitude and a certain phase relative to the fundamental tone. So as I'm talking, the codec is first of all trying to estimate, well, what's the tone at this moment in time, and then look for the harmonics and what's the amplitude and phase of all the harmonics of that tone for this short period. So you break the speech up into lots of little bits, look for the bass tone effectively of all of those little segments, and then the relationship of the amplitude and of the harmonics to the fundamental. And when you've got that information, that's the information you send. It's a tone of this pitch. There are 23 harmonics. Each one of them has the following amplitudes and phases in a very, very crude manner. And that's sort of illustrated here. So you start with a fundamental at frequency 1, and you add together all the amplitude and phases of all the subsequent harmonics, and you can produce this complex waveform. And if we look at this, I'm going to have to try and use my pointer. So I don't know if you can see, but let's find an appropriate point. So for example, if you look here, you can see that that's the original, and it's a male speaker, and then you can see here, so if you look for that pattern there, see that pattern is repeated, delayed in time, but this is the waveform that's been put together by just looking at the original fundamental frequency and then the phase and amplitude of each of the harmonics. So it's not quite the same waveform. If you look closely, you'll see there are some areas where it's not quite the same, but it's a pretty good representation. And so by breaking the speech up in this way, we can really reduce the bit rate needed to represent the speech successfully. And that's a block diagram of how this particular codec works, which I won't bother to talk through, but the pitch, this is the pitch estimator I mentioned, and this is the harmonic analysis. Okay, and then the last thing to mention about Codec 2 is that it also uses, at least on the HF bands, this thing called an Ofdm modem. And in an Ofdm modem, you don't just say, okay, I want to send 700 bits per second, so I'll send a bit stream, you know, going at changing 700 times a second. What you do is you have multiple carriers, and then you say, well, I'll modulate each one of those carriers with a phase shift at maybe 50 bits per second. So to get 700, I don't know, I've got to do that in my head now. You could do that with, let's think, well, you could do it with 70 carriers each signaling at 10 bits a second, or you know, 7 carriers each going at 100 bits a second, and you know, there are variants. But what you also arrange is each carrier will be changing in phase. So just like if you think about FM, you get the fundamental, and then you get these side bands that are associated around the center frequency of the FM signal, where you get the same thing at baseband, and you arrange for the null of between each of the side bands to fall in the same spot as the place for the next carrier. And and so they're sent orthogonally, so one doesn't interfere with another. And hence you get the acronym orthogonal frequency division multiplex. And this is the type of modem that's used, And the reason why it's good on HF is because HF channels fade selectively. So half the channel fades out and the other half is still good. So at any time, some of those carriers get knocked out, but the others stay preserved. So most of the message can get through, and then you can put some error correction to compensate for the ones that you lost due to the selective fade. And that seems to work quite well. Okay, so that's a bit of the background and the theory. I hope that wasn't too painful. How do you get on air? Well, essentially you download the software and run it on your PC. It's not complicated. This is the application. There are versions to run on Windows, either 32-bit like the older versions of Windows, or 64-bit Windows versions of Windows. It'll also run on a Mac under OS X, and it'll run on all the various flavors of Linux. Essentially allows you to take any SSB, HF or VHF radio and use it with the digital modulation, and provides you with some controls to switch the digital mode on and off, and key the radio, and so on and so forth. And I'll show you the demo in a bit. It supports use at FM using a mode known as 800XA. So it's the same codec, but instead of using the Ofdm modem, it uses a more traditional 4-level FSK modem, which I think is the same as one of the digital. Oh, it's the same as DMR, I think, isn't it? Is it? Yeah, C4FM, similar to C4FM. So it's a different modem, but it's the same voice codec, and I'll show you a video of how that works a little bit later. It supports a variety of modes. 1600 bits a second, which is the first version of FreeDV. It's been out quite a while now. Some of you probably heard of it already. 700C, which I gave a talk last year and gave a demo of 700C last year, but basically now everyone's moved to the new version of 700, which is 700D, and that has better performance, as you will see. And then it supports the VHF mode 800XA. So diagrammatically, again, you have a PC. I used a very old picture of a PC off the internet, but you know, we all know what a PC looks like essentially. And then you need to connect that. You need an audio source and sync for talking into and listening to. Yes?
Yeah, so quick question. Is there enough steam in a Pi to run this codec?
Yes, it will. It'll run on a Raspberry Pi, yes. That's a good question. I should probably use a Raspberry Pi in the picture actually, because that infers you really need a PC, but it'll run on a Raspberry Pi, yes. So you need an audio source, and at home I use a quite cheap USB headset that I bought from Amazon. I'm not allowed to say that probably, but you know, well-known online retailer, which was actually very inexpensive, but works really well. So just a headset with a microphone and USB connected into the PC, but you can use whatever you wish, of course. And then you have to put audio into your transceiver. So you know, you can do that by building your own interface, or you can do it via one of the available interfaces like a Signal Link or a Rig Blaster, I think that one is. Or if your radio, like most modern radios do, has a USB connection directly for audio, then you can just use that. And that's what I'm going to use with this ELAD FDM Duo. So I've got a USB cable going to a small USB hub because I need 2 sockets, not 1. And one of these carries the audio and the other one carries the PTT. Okay, so it's not difficult to get on the air. Download the software, and this is not any different to the setup you would use for any other digital mode like FT8 or PSK, or you know, the various other ones there are. You can, if you wish, purchase this unit. This was developed by David Rowe. It's available online, and it includes a processor and a speaker and a microphone, and essentially you don't need a PC to run with it. But at the moment, this only supports the 1600 bits per second mode, and it needs updating to the 700 bits per second mode. So I personally wouldn't use that at the moment until it's updated. But the schematics and all the software are freely available. So if you don't want to buy the ready-built one and you want to make your own PCB, then all the Gerber files, schematics, parts lists, everything you might want to build one are also available. So modes, different modes. As I said, FreeDV started at 1600 bits per second. So this was the first version of Codec 2. Codec itself ran at 1300 bits. It's 25 bits a second for a little bit of text. And it used a modem that was taken from another effort to put digital voice onto HF, which was called FDM DV. 16 carriers, each at 50 bits a second, essentially. And that was pretty good, and you could hear conversational speech down to about +6 dB signal to noise. So scratchy SSB, but not getting to beyond SSB. Now really the most up-to-date version is 700D. I do the RSGB news in FreeDV every Sunday morning on 80 meters to provide a test signal, mainly, for people to, check and see if they can get the mode up and running, and use 700D. So there, in this case, there are 17 carriers at 75, each carrier running at 75 bits a second. Codec 2 runs at 700 bits a second. There's space for a bit of text, so I'll send you my Twitter ID on the text should you want it. It uses something called transmit frequency diversity. That means that, you remember that Ofdm modem, and I said there are multiple carriers, and while some are fading out, the others can still be okay. In transmit frequency diversity, you're sending the same piece of information on more than one carrier. So if some are knocked out, that bit still gets through because it's being sent in another part of the overall, I think they call them bouquet. I don't know, but I think so. And this can give you conversational speech to -2 dB signal to noise, which sounds horrible in sideband. It also does include interleaving. So interleaving is where you don't send bits that are near each other in the data packet actually next to each other in the stream you send over the air, because if you've got a fade, they all get knocked out at once. So you move the bits around so that some of the bits in the packet are sent quite quickly and others are delayed by a bit, and you hope then when you unscramble all of that, the fades have knocked out a few bits quite regularly through the packet rather than lots of bits all in one chunk. And if you've got a few bits regularly spaced throughout the whole message, you can use error correction to fix them. So it gives it a bit of more robustness over the air. But it does have a consequence, which is that you have to wait for a second or two for the thing to sync before you can hear what the person at the other end is saying. So you can't just press to talk and talk. You have to press to talk and just wait for a second and then talk. You can turn the interleaving off, but then the ability to handle noise is slightly degraded. I mean, we're talking like about a dB or 2 dBs, but in this application, every dB counts. And the more interleaving you have, in other words, the longer you're prepared to wait at the beginning, the more resistant to interference it can get. Okay, so this is my first sort of little demo, and this is a demonstration of FreeDV 800XA. So this is the mode that uses the 700 bits per second codec with the 4-level FSK modem for use at VHF. This used to be, I should explain the video you're about to see, because it was really difficult for me to find a video on the internet of this. This started life by using the codec at a faster speed, and so was called 2400B, I think, or some other name. So during the video, the person talking will say, I'm testing but it's actually FreeDV 800XA. They just changed the codec slightly. Right, here we go.
Hi everyone, this is Brady, KC9TPA. I'm out here in the middle of nowhere, Illinois again to demonstrate the other new FreeDV mode we've been working on for the last couple of months. We're calling this one 2400B. It's designed to operate over cheap analog FM radios and come close in performance to analog FM. So I'll go ahead and start the transmission here. On the transmit end, I'm using a Yaesu FT100, and on the receive end, I'm using a UV5R. Since I have the UV5R hooked up to the computer, you can't hear anything coming out of the speaker. The software I'm using, FreeDV RX.
This is Radio Brian, KC9TPA, Kilo Charlie 9, Tango Papa Alpha, testing 3DV, the VHF modes 2400A and 2400B.
And I'll go ahead and run that again without the little clutch cable here so you can hear what it sounds like over FM. And I'm a couple of kilometers away from the transmitter.
This is Radio Brian, KC9TPA, Kilo Charlie 9, Tango Papa Alpha, testing 3DV, the VHF modes 2400A and 2400B.
Okay, so what you heard there was over the air, you heard the FreeDV, then you heard the same test transmission sent as a narrowband FM signal. You could hear some codec artifacts in the first, but then you could hear quite a lot of noise and hiss in the analog version, and then what you heard at the end was listening to the modem, but on an analog radio. I think they forgot to turn the camera off right at the end. So basically that's competitive with probably sideband today. It'll be better than D-Star or DMR simply because the codec's going slower, so you can you can use less bits per second. So the bandwidth of the transmission's a bit less, which means there'll be a bit less noise contribution. But essentially not a radical change.
Hi everyone.
Oh, sorry. So this have I got two? I've got.
Hi everyone.
Yeah. Sorry, I'm a little confused. Right. So now I'll do the live demonstration of FreeDV over HF, and then I'll just come back and talk about a little bit of the operations that we've achieved so far. So first of all, just get rid of the PowerPoint. So I've got on my PC, I've got a test signal, and it's just me talking. You probably heard enough of that already, but
Juliet, G6WPJ transmitting.
that's the original. Okay.
A demonstration at the.
So I just thought I'll prove to you it is on my PC. You know, I'm not faking it. Now what I've done is I can tell the software to, instead of listening to the microphone, use a file from my PC, which I've just done there. So now if we start the software, what's happening is that at the moment nothing's being sent from the PC because I haven't pressed the PTT. But the radio is in receive on some random frequency on 10 meters, and the audio from the radio is just being passed back to the software, and we're listening to what the software is sending out. Sorry, it's a bit loud. So now what I can do, if I press the PTT, that signal, that file that's on my PC, will be sent by the software to the radio, modulated as a sideband signal, upper sideband, transmitted at a 1 milliwatt output, so very low power, to this very bad antenna for 10 meters, which will radiate about a centimeter into this dummy load and then come all the way back. So it's simulating a very bad sideband path on 10 meters. And if I start the PTT, you'll hear what that sounds like. So you can hear there's something there, but you can't really hear what's being said. So I'll turn off analog and switch to digital.
And just the person before I finish, I'll switch back to single sideband and finally sign in the sideband. CQ, this is the 6WPJ. Signing off this demonstration.
No background noise.
FreeDV.
There's lots of codec artifacts, but if you look at
56WPJ signing and saying 73 or at the RSGB convention
1 dB signal to noise.
73.
And we do need to. Sorry?
I swore.
Oh.
Something held. Brilliant.
Okay. I'll just try that again so you can listen to it again in sideband. So that's what it sounds like in sideband. And then again we can switch to digital.
2018, and this section of the demonstration is being sent in single sideband high frequency on 10 meters.
Now the codec does take time to get used to. You know, you have to have the right ears on. But in truth, that's not any different to sideband. I have sideband on in my shack, and my wife says, "What's he saying? What? What did he say? I can't understand a word of it." So sideband's not any different. Okay. So that's the demo. And I mean, I think you know, the demo says a lot better than I can. It says it very eloquently, much better than I can actually. It's a really interesting new mode. It is very new. It hasn't had, you know, all the polish of a commercial company making it all nice with, you know, caller IDs and all the other stuff. It's just the codec itself. But actually, in the use of FreeDV to read the news, people actually really like listening to the news with it because it's much easier to listen to than listening on sideband. And then if you're just having sort of like a, I don't know, you want to call it a rag-chew conversation, you know, a conversation rather than a DX contact, it's actually a lot less tiring to listen to. Okay, so where can you find activity? So there's a net. So first of all, 14.236 is, if you like, the worldwide. You might find a QSO here. There is this site called the FreeDV Qso Finder, which you can find at qso.freedv.org. And if you want a QSO, you can go there, and you might find another station who's also looking for a QSO, and you can arrange to meet on air. There's a net every Sunday morning at 11 AM local time in the Netherlands. That's 10 AM here on 3.625 megahertz. Certainly in the southeast of England, you can pick them up very easily. They're all quite strong signals. There are some activity in Australia. I read the news on normally 3.643 megahertz at 9 AM UK local time. And there is a net every day on or near 3.697 megahertz. And that was started by some stations at GW stations, but they're on nearly every day, and they seem to have, they've been doing it like for more than a year now. It seems to be a very regular thing. I think they may have changed frequency recently because of some QRM, but only just like a couple of kilohertz. And the transmission's very obvious because you know what sideband signals look like on a waterfall. Well, the modem tones looks like looks like a bit like a very narrow version of Easy Pal, if anyone's had a go at that. Right, we'll just talk a little bit about, there is one more mode in development, and this is running the codec faster so that the quality is better, but not using the same design techniques as have been used for D-Star and DMR, so using an SDR radio, so getting at the digital information earlier in the signal processing chain. And by doing so, they can get a better system performance, about 10 dBs. So this is called 2400A, and this essentially would give, it requires a little bit more bandwidth than is typical on a sideband radio, so you probably need to build a radio specifically for it, or use an SDR, take something like, I don't know, the dongles, the RTL dongles, or an SDR play or something like that, and then do the rest of it in software in your PC. But the performance is really quite startling, and I'll give old Brady the chance to give you another demo. And I think you'll be quite surprised by the performance.
Hi everyone, this is Brady, KC9TPA. I'm out here in the middle of nowhere, Illinois today to demonstrate a brand new FreeDV mode. We're calling this one 2400A. It's designed to operate on VHF between SDRs, and it's designed to work at an SNR well below that of analog FM. On the transmit end, I have set up about 2 kilometers away at my QTH a HAC RF1, which has a transmit power of somewhere between 3 and 30 milliwatts. And on the receive end here, I've got an RTL SDR with a BNC connector clutched onto the side. So I will go ahead and start the transmitter now and switch over to the receive software. To receive, I'm using GQRX, and I have that pipeline into 3D RX over UDP.
So you can hear the analog FM, you can't hear anything.
This is Radio Brian, KC9TPA.
And then once he
Kilo
switches to
Charlie
digital.
9, Tango Papa Alpha, testing FreeDV, VHF modes 2400A and 2400B.
Okay.
Hi everyone.
I've got 2 of those, I don't know why. Anyway, I think we've talked about most of this, so I won't labour the point because we're getting towards the end of the time. Thanks to the RSGB, they got me the license to be able to do FreeDV news broadcasts, which I was grateful for. The Dutch amateurs that have that net on 3.625 for the first few months at least were the only people who ever came to say hello, so so I have to thank them publicly for their support. Or more recently, there's been a lot more G stations active. I do want to mention G4ABP, Mike, and GW3OAJ. Both of them have been really supportive of my efforts to publicise FreeDV. And it was GW3OAJ SES who organised the net on 3.697 every day. So he's done lots of work, and he's really worked hard to improve his audio quality and get it as good as it can be. And if you listen to his signal, it's a lot better on air than mine. Okay, so I think we're done. If you're interested in contributing to the work, there is a shortage of suitable C programmers, people that write DSP and codecs and so on, and I'm sure the group would value any further efforts should anyone be interested. And that's it. I think we won't summarize, but if you want to know more, there are some website addresses and emails and so on. Thank you.
Well, thank you very much, Matthew. That was an excellent talk and fascinating. I think I might well be downloading the software myself. Now, we can throw the floor open to questions. So anybody like to ask any questions? The microphone will be coming round. Stick your hand up and we'll take questions from the floor.
From G6KUI, named Peter. After last year's talk, Matthew, I came on to listened to your RSGB news broadcast, and we had a good long talk on it.
Right.
And I found it quite enlightening. But after that, I couldn't find any other stations to talk to. So has it improved vastly since then, or is it still at the low level?
Well, it is at a low level, and but there was, when the new version 700D came out, there was quite a flurry of activity whilst, people who had been interested all tried the new version and saw whether it worked at, work even lower signal to noise. So there was a bit of a flurry of activity. As I say, I think that the net that's on nearly every day from the Welsh group is really valuable, because certainly they're getting callers not just around GW but also from GM, further north in the UK, southern England. So it seems to be an almost UK-wide net, and they've done a lot of work. I can't remember his call sign, but he actually built a Class E power amplifier to try the 800XA mode on 80 meters. So he went and actually built a power amplifier just to try this new mode. And they've done a lot of work on improving audio and giving each other reports. And they seem to be having good results. So that's a good place to try. Every day at 4 o'clock local time on 80 meters. Yeah. 1600 BST and then 1600 GMT after we change the clocks.
It's Dave, G3YXM. I've tried FreeDV years ago when it first appeared, and I was a bit off put by the quite low fidelity, if you like, of the audio. And obviously work's been done on that, but it still sounds a little bit restricted to me, and I wondered why you'd gone for such a low bandwidth, because it's half the bandwidth of an SSB transmission, if you say about 3K. Wouldn't it be better to widen it a bit and make the quality better, or does that lead to more selective fading issues?
Well, I think David, who is the prime person who's been doing the coding, David Rowe, I think he wanted to get it to the point where it could outperform sideband in terms of weak signals. This is a one-man, in the sense of doing the codec, it's a bit of a one-man effort because no one else has got the skills that he has. But it's my understanding that he is now working on a mode where he's going to take the same codec but run it faster with a faster modem to increase the fidelity and just take a little bit more bandwidth. So a more conversational version rather than a DX version, if you like. But it all takes time.
Yeah, hi. Just thinking about the different codec modes. And a lot of the commercial stuff, as probably a lot of people are aware, is signaling goes on across networks to agree what's going to be used, and then you carry on. Obviously, in the world of amateur radio, you can't do that, but you can do in-band signaling. There's wondering if there are any plans to add that sort of capability, so there's more maybe automatic detection and switching within the codec and that kind of. I know it's quite complex. I realise that. Is there any thinking on that?
I think there is. I think it's all about effort for people to do. I think David's view is he's done the codec, so he's done the fundamental research. He's proved you can get speech into this few number of bits with relatively reasonable set quality, and it's out there in open source. So if someone wants to add signaling and data capabilities and call and station calling and all of that, well, look, go ahead, feel free. It's But I wish I had the skills. But I don't, I'm afraid.
Hi. I just wanted to mention, kind of as more of an info point than a question, there is full GNU Radio support for Codec 2 and FreeDV in GNU Radio.
Right.
So if you have an SDR like the Pluto or similar, you can do the full receive and transmit using these wider modes. Using that, and it also supports changing the parameters. So if you want a higher fidelity audio mode and you're willing to go to 10 kilohertz bandwidth, you can just basically select that as a drop-down option and get FM broadcast quality audio just over a wider channel. But then you're pretty much talking to yourself unless you have somebody on the other end
Yeah.
with
But
similar hardware.
that's-
But it does work.
Great. Thank you very much. That's really interesting information. Thank you.
Well, if there are no other questions, Matthew, thank you very much for your very interesting talk. Really, this demonstrates amateur radio in action. This is what we do. We experiment. We don't just use it to talk. We experiment. That is the essence of amateur radio. It's radio amateur at its finest. So I say, why not download the software, join in on the net, fill up the band with it a bit, and make it develop, because the more people that use it, the better it will become. Thank you all for coming.